Okay, let's start. We finish the relational algebra section and we move on to SQL. I'm going to give you another exercise of relational algebra later. Let me talk a little bit about SQL and then we'll do the exercise of relational algebra. Okay, so first of all, let's see our roadmap. What we did so far is we start with requirements, right? And then we have ER, and then we talk about relational model. And we also talk about mapping from ER to relational model. And the next thing is we did talk about relational algebra. Once we have relational model implementation, we can use SQL to implement the design. So this is design, and this is the way to use programming. So this is like a coding part, right? So we use SQL to implement what we learn in what we produce in relational model. In other words, like when we have tables, R, S, have everything, we can use create table R, create table S. So that's SQL statements here. Okay, so the next thing I want to do is, so let's first see the history of SQL. We have different versions of SQL. The most recent version is SQL 3. It consists for a core part and the extension part. The core part is supposed to be implemented by old relational database system, and the extension part is optional modules. For SQL as a standard, that means all the relational database vendors, no matter which company, they should support the SQL standard and implement the core part there. But in reality, okay, so most their vendors, whatever they provided, follow the SQL standard, but you can easily see they all have their own stuff. So for example, there are things that specify in SQL standard, they have slightly different syntax, okay? There's some part they didn't implement, and they may have some extra on top of what SQL standard. So this is something you should know. You don't expect any vendor, they actually 100% follow SQL. So you will see small variation of things when you move from one system to another system. And also the recent standard always have new updates, like incorporate like XML, object database features, those things into SQL. So now we finally be able to see what is the date definition language, DDL here, right? So we keep mentioning about that right now. Now is finally we will to talk about create table statement. That's part of data definition language. So this one allow us to specify a new base table. So when we say base relation, that means anything that we use a create table statement to produce, and that's physically saved in the disk. And later, at the end of SQL section, I'm going to show you something called a view. And compared to base table, that's saved in the disk, and view is a virtual table. So we'll do that later. And when we create table, the syntax wise, we have create table, and then we have the name for the table. So in a given schema, any table must have a distinct name. Okay, so that's similar like you draw ER diagram, different entity, different names, right? So we have different name, and usually what you produce in the relational model, remember we have, you know, R, S, and we have foreign key, all those things. So you just follow the same name in your table definition. You don't have to, you know, as long as you give meaningful name, but most people just follow what they design there, but because we don't want to think again for a better name or something, but you can have different names. And so we see create table and table name. Then the next thing we want to do is we want to specify the attribute name here. So the first one is the name, and that's also something we can follow our relational design. So let me go to here. So this is the design, right? So for example, for the department table, I have a D name, D number, manager assistant. So you use, this is the table name, and this is one attribute name. This is another attribute name. So we can follow exactly the same thing in SQL. Okay, so here we see D name and D number. So the couple of things here. So first of all, uppercase, lowercase matter or not. So in SQL standard, there's no specific restriction on that. However, when you use a different DBMS system, some of them, they are case sensitive, some of them are not case sensitive, and some of them allow people to set up whether they are case sensitive or not. Right, so this is one thing you want to pay attention when you use particular vendor's product. And for MySQL, so when you use MySQL, what happened is this is one actually depends on the server's operating system. So for the account I give to you, I'm going to give you account, and you're going to receive your account through the Canvas email. So you will see two lines, and the first one is username, and the next one is the password. I'm going to actually, you need to, so I'll get a little bit away from here. But anyway, so for MySQL, for the account I gave to you, it is case sensitive. Okay, so make sure you know that so you don't see surprise when you do your SQL assignment. The account I gave to you, because of the operating system of the server, it is case sensitive. Okay, so in other words, if you define the name like this, compared to define the name like this, compared to define the name like this, they are treated as three different attributes. Okay, attribute names. Okay, so since we talk about MySQL, if you go to Canvas, you should be able to see something called Canvas in the called the MySQL instruction. And so from there, you will to see the detail line by line how to log in the system. However, I need to give you the username and the password. Okay, I need to send this kind of things to you. So. Okay, all right, so go back to create table statement. So we see the attributes here. So we see the attributes, and each attributes, we need to define a type for it. And this is something called domain constraint. Remember, we learned different type of schema-based constraint. Domain constraint is one of them. Remember in the relational model, actually, how about let me open that. Okay. Okay, so this is the one we learn different constraints, right? So we learn different constraints, and they are schema-based constraint, and like a domain constraint, key constraint, constraint on the no value, entity integrity constraint, referential integrity constraint. You will see each of them one by one in the SQL definition, right? So remember I said, in the create table, now it's time you'll be able to see them. Let me go back to this. Okay, so we have the name, and then we specify the type, that's the domain constraint. And another constraint is no-to-no constraint. And this is the one restrict for any department. The department name cannot be a no value there. And the same thing for department number cannot be no value. So we can define the type of each of them. And so let's go a little bit further on the type here. Okay, so first of all, we can define numeric type. So for example, integer or int, actually they mean the same thing in SQL. And we can define other things like a float or real. And we can also precisely give how many digits we allow. So we can do decimal or numeric. And that's the first one, specify total number decimal digit. And the second one, J, means how many digits after decimal points. So this is where you can accurately specify the format and also how many digits in a decimal number. Okay, and the character string, there are two different types. One is fixed length one is varying length one. Okay, and for fixed length one, this is useful when you know exactly how many characters we need. So for example, we can define social security number as a character, and this one I can define its character 9 here because we have 9 digits. So when I write down things here, you may ask, again, case sensitive or not, if I use this or that, do they make difference? And actually, no. The reason they are not case sensitive because they are predefined by the system. Whatever case sensitive I was talking about using the account I gave to you, that's a variable you define, like an SSN. That's something coming from you, right? But this is like a more like a keyword or system defined type. They are not. Also, when we do create table, you can say create table, no problem. This is recognized because this is defined or produced by the system, not by you. Okay, so go back to this, and we have social security number, and we have 9 digits here, right? So we can specify totally 9 because we know social security number is exactly 9. So that's a good case, a good example to show you can use a fixed length one to define this. Okay, another one is varying length. This is the one we do not know exactly how long. So if we say a name for the department, and we can say varying character, and I say 30. So that means maximum I can take 30 characters. In other words, we need to restrict how long is the department name here. So this one, if you define too big, you're actually wasting the space. But if you make this too small, it cannot accommodate all the name, like longer names. So this is basically depends on specific application, how you set the limit here. So that's the maximum number. You don't require every single department to be like a 30. It can be less than that, but cannot be more than that. Okay, so this is a fixed length one. So character is a fixed length, and the varying character, the word chart here, is the one you specify the maximum number, and you can have things variable length, right? So you can have like a smaller, like only 10 character, that's fine too. Okay, so that's the difference. And so what I will do here, actually, let's finish the exercise in relational algebra. Let me stop this. Let me share to here. Okay, so we have one more thing need to do on this. That is using a set operation to answer a question. So I'm going to put this question here. So let's do a in-class exercise. Okay, so this in-class exercise can be done in two different ways. One is using set operation, the other is using join operation. So since I just finished this one using set operation, you can try to use set operation to handle this one also. And if you don't want to use a set operation, you can use the join operation to do things similarly. In assignment question, relational algebra assignment question, actually in any assignment questions, you give me one and only one answer. If you give me multiple answer, I'm going to read the very first one and the grading based on that. I ignore the rest of them. Okay, but for this particular one, if you know both approach, you can try. It's just some way to see, which one you understand both, or which one. But as I said, one, only one, give me one, only one. That's all you need to do for any assignment or exam questions. And after you finish the exercise, I'm going to show you the solution of both using set operation and the join operation. I give you another 5 minutes to do this, maybe 6, since some of you may want to try both. 6 minutes on this. All right, so let's take a look about the solution here. So first of all, I'm going to show you how to use set operation to do this. And we can see I need a manager, right? So if I know the manager, okay, then I want a manager have at least one dependent. If I know this is a manager set, and this is the employee have at least one dependent, then this part is what we need, right? So basically we do need two things. One is the manager, one is the employee with dependent. And so how to get employee with dependent? We just finished that, right? So we know how to get an employee with dependent by doing a projection on the dependent table. Okay, that's good. Okay, and the other one is how to get a manager. And so this is another one we kind of know how to do because we did something similar. So we see this manager SSN field here. When we have department table, this one actually give me all the possible managers, because if somebody is a manager, then the SSN must show in the department table. This one has all the manager SSNs. So if I do a projection on manager SSN, then I'd be able to get all the managers, the SSN of all the managers, right? So similar, when I do a projection here, I get all the employees who have a dependent, at least one. Okay, so then problem solved. So we just follow this logic here. So let's see. First of all, let me get, this is the manager and this is the employee with dependent, right? So let's get the manager first. what I need to do is I do a projection on manager assistant here. And okay, and CM code managers. I need to rename this manager assistant into assistant here. So when we do things further, we can just utilize assistant. So if you don't want to rename it, that's okay, because we can rename the next one for the dependent table to do the projection. Okay, so this is the one we have e-assistant. So we have this, right? So one way is, instead of we can avoid renaming this and using manager assistant, then you have to rename e-assistant into manager assistant in order to make eventually they can do the intersection operation, right? So you have to do it. And so what I will do here is to actually make things easier. I'm going to also rename this into SSN. So I rename both into SSN. Again, this is not necessary, since I'm going to do intersection of this two. You can just rename one of them, then that's sufficient. Okay. So then I have this one. That's this result. So now you see I have SSN here. I have SSN here. They're exactly the same schema. And I want to do intersection according to the semantic. So I just need to go ahead to do the intersection for two intermediate steps. And then I do intersection with this. Okay, and then I can produce a result. Right. Okay, so this one, since SSN, then this one has SSN. Okay, but this one has first name, last name, so I don't have them. So how can I get it? Since I have the primary key, I always can go back to join with a table. Employee table has first, last name, right? And I have the SSN there, so I can join with the employee table. And in this case, since this is the one called SSN, an employee also has SSN, so I don't need to rename them. I can just go ahead to do the natural join. Okay, so I have this result. I can, if I want to do, I can rename. I can rename one of them into something, and you can do the drawing if you want. And again, as I said, why bother? This is easy. Just join them to get the result. And once I finish this, I can do an intermediate result. And the last step, I do a projection. But here, I just combine two steps together. So I need a first and last name. Okay. So this is the way using intersection set operation. Another way to do this is using a join operation. Let me erase this. Okay, so what I will do here is I can take the department table. Okay, I can take the department table. I can join this with the dependent table. And so when I join that, I'm going to take the manager SSN coming from department table, right? Remember, if this is equal to ESSN from dependent table. So what is the case when they match? You know, anything in the manager is actually here, right? And they match the dependent means, you know, if the manager has a dependent, then this ESSN will be somewhere there. But if the manager has no dependent, we are not going to see that in the ESSN. So this way actually make dependent and department, we'll be able to join them directly to get the result. Okay. And this, in this case, we can see we have a lot of attributes in this result. Okay, so let me put this one here. Say we call the manager dependent here. So when we have this result, we have many columns, but we do not have the things we want. So first name, last name, right? So how to get first name, last name? That is the one using employee table. So I can take employee table and join with the manager dependent table. And my condition is using the SSN for employee, join with, for example, ESSN. Okay? You can also use manager SSN because they are equal anyway. Okay, however, I haven't done the last step. This is wrong. Okay, what's wrong? That is when we do this. Okay, so this step using the employee schema, this one is what is the schema of this? This is every single department, every single dependent, right? And so every single department, no problem, but every single dependent, we have an issue when you eventually join with the employee because this whole result taking the whole thing down to join. So dependent, okay, so since it's including all the attributes of dependent, then we have issue because dependent has this one, right? When we join like the department, so our intermediate result schema is every single department, right? And with the dependent or the attribute. And when we join this with the employee table here, we see this column, and we see this column, right? So when we join this result with this, I see exactly the same column names. So that's what I mentioned. If you write down the intermediate result schema, although it's waste time, okay, you put in the scratch paper, waste you some of the time, you spend some time on it, but you can clearly see you made a mistake. I mean, I made a mistake right here, you know, if I don't do anything. So that's wrong since we have things like that. So I have to do something in order to make this happen. That is, I have to do a projection to get rid of something that I don't need for the next step. Basically, 2 column B data and the sex. I have to get rid of the 2 columns. And then I found out, actually, I don't need anything beyond the social security number, right? So I can do a projection to get rid of all of them, only keep the social security number. Okay, so on top of this result, I'm going to do a projection and say I take ESSN column. Okay, you can take a manager SSN, but here you need to use manager SSN either way. So I take this. Now when I do this, I only have 1 column. That's the social security number of those managers who have to have at least 1 dependent. So then this result is actually same as, oh, I already removed, sorry, already removed that. So same as the one we did for the intersection result, right? And now we can join with employee and to get the first name and last name here. Right, okay, and so on top of this, right, so I have all the attributes. I only need first name, last name, and I have the result. Okay, so that's another solution. Depends on which way you prefer to answer it. Either we can solve the problem, but remember, whenever you have more than one tables, especially you carry down to the next step, you want to see if you need to rename columns or get rid of columns or not. In the case there, if you don't have any conflicting names, you don't have to do projection at all. You know, for example, this is because 2 columns, right? Exactly the same, so you have to. And I think I also talk about if you don't want to do that, you can do renaming also. So those 2 columns like exactly the same, right? So one is B date, the other one you can rename into birth date, and then you can do this without problem. But it's nothing useful to do the subsequent step when you answer the question. So I think a projection is that a better way to handle this. Okay, so we still have some time. Let me go back to SQL. So everything of relational algebra is done at this point. So let me move to SQL. All right, so finish this already. So let's see other type. We also can have a Boolean type. That's basically true or false. And remember, we talked about like a smart room, right? So in this case, it can be true or can be false, whether a classroom is a smart room or not. And date, this is the one usually we be able to specify year, month, day, in the following format. And time can be hour, minute, and second in the following format. This is like a more typical format we have, but we have a lot of different data format in most of the database vendors. So most of the database vendors, they give different type of date you can use. You don't have to use this format as long as they allow you to use others. This is the number one thing you want to pay attention when you convert a design or implementation from one system to another, because the definition of date can have difference and you may have problem merging to other system if you don't pay attention. Okay, so let's go further about create table statement. We can specify much more than just domain constraint and not null constraint. You can do more than that. So starting from this, we'll see what we can do here. So in this create table statement, we can specify something called the primary key. All right, so you can see I define the name, type, and not null. We can define the number, manager assistant here, and then we can define something called the primary key. So simply just say primary key and you give the attributes here. Then the question can be, how can we do composite primary key, right? So when primary consists of 2 or more attributes, how can I do it? So you simply do the same way, but you use comma to separate them. So we can see primary key, building, comma, and room number. That's it. Okay. Okay, so that's the way to specify primary key. You can also specify primary key directly along with the attributes, but when you have composite, you have to do this way. So instead of thinking about 2 different ways, probably just easy way, just do this directly. Okay. All right, so you have primary key. Okay, we have primary key here, and then let me go to the unique here. Remember, in relational model, we can have a couple of keys and we pick one of them as the primary key and we underline them, right? That's what we learn. And we have other keys. They are not get selected as a primary key. And we have no notation in the relational model to present that. Now is the time. So in the create table statement, we be able to specify unique. So if this is another key, we can say unique and we put a key there. And the same thing, if it's composite, just do a comma to separate the composition. So that's a good thing. You can specify something is unique, although this is not a primary key, but when we insert something, since you put a unique on string, the DBMS will not allow duplicate value for this unique dname here. So that's something very useful when you want to enforce the uniqueness of attribute. And this attribute, unfortunately, was not selected as the primary key. Okay, so we can see another thing is, since we make the number as the primary key and we have not null there, and that's the one called the entity integrity constraint, means any primary key must have this not null constraint. And I know many systems, you don't have to explicitly specify that as long as you specify as a primary key. But still, this is the one actually, if you want to, doesn't hurt to specify here explicitly. So that's basically enforce the entity integrity constraint. Okay, and then the next one is we can specify check here. Okay, so this is the one allow us to narrow down the values. So say for department number, we only allow things between 0 and 21. So from 1 to 20, then we can using this check to further restrict these numbers. And remember one thing in MySQL, there are many cases like this one, you can specify, but they don't enforce it for you. Okay. So this one's supposed to be enforced according to SQL standard, but MySQL, you can specify, just doesn't enforce for you. Okay, and the next one is the foreign key constraint. So this is the one we specify foreign key which attribute reference to which table and which attribute. So this is usually the primary key, and this is the foreign key reference to the primary key. Although sometimes in some system, for example, Microsoft SQL Server, you can reference to another unique attribute, but just simplify the discussion here to avoid confusion. Think about like a different vendor's product. You always reference to the primary key. That's actually should be the normal practice. Only reference to primary key, and this whole thing you need to specify which is the foreign key, and reference to which table, and reference to which attribute. That's the primary key here. Okay, and if we have a composite foreign key, then what can we do? Same thing using comma, right? So A, B, right? A, comma, B, reference to another table, then this table must be similar format, for example, D and E, something like that. So foreign key, primary key need to be the same domain, right? So if this is two attributes, A, comma, B, and the other one must be something like D, comma, E, for example. Okay, so that's just wrap up of this, and we'll have other things in the next class. Okay, that's it.